If you want to try this one on your own, go ahead and pause the video, but I'm going to go through it in 3, 2, 1. So we've got a regular pentagon. We're extending two of the sides and they meet at a point called F. What we want to know is the measure of angle F. Well, we know that this is a regular pentagon, and regular means that all of those side lengths and all of the interior angles are going to be congruent. So I have 5 interior angles, and if all 5 of them are congruent, then I can find the sum of all 5 and divide by 5 to find the measure of just one of those angles. I know that the sum of the interior angles is going to be the number of sides decreased by 2 times 180. Well, in this question, I have a pentagon, which has 5 sides. So solving this, I find that the sum of my interior angles is 540 degrees. Well, if I want just one of my interior angles, let me take this 540 degrees and divide it by how many angles there are, which in this shape there are 5, and that gives me a total of 108 degrees, which means that every interior angle in my pentagon is 108 degrees. So specifically, angle EDC would be 108 degrees, and angle BCD is 108 degrees. Now this is helpful because I can then use the fact that angle EDC and CDF create a linear pair, meaning that they have to add to 180, so this angle here has to be 72 degrees, as does angle DCF. Must be 72 degrees because we have another linear pair here. Now I can focus on triangle DCF. I know that in a triangle, all 3 angles add up to 180 degrees, which means the measure of angle F plus those 2 other angles, which are both 72 degrees, all has to equal 180. So solving this, I can find the measure of angle F. Subtracting my 144 from both sides, I see that the measure of angle F is 36 degrees, and that is all.